Okay, a question came. They said the box is 2 kgs on top of the building cliff, okay, and takes 3 seconds to fall, and takes 3 seconds to fall. Okay, so this is a building now. So this is a building, okay, that is a ground. This is a box, okay. This box is 2 kgs, okay, and then this, it is falling down here. It's falling to the ground here. That's why it's falling to the ground. So it's on top of the building there, that box, and then falls to the ground. Question one is, what energy does the box have on top of the building, or before it falls? What energy does the box have on top of the building? Or before it what? It falls. So what energy does this box contain here at the top here before it falls? What energy does it contain? It always contains potential energy. Before anything falls, it contains potential energy. So the answer there is potential energy. What energy does it contain? It is potential energy. That's the question. That's the answer for question 1. That's the answer. Potential energy. Potential energy. See? Question 2. What is the height of the cliff? When I say cliff, I mean that building, cliff or building. What I mean when I say cliff, I mean building. What's the height of that building? Under equation of motion, there is this equation that we usually use, this one. If you remember this equation, x is equal to ut plus half gt squared. This x here, it's symbolic of distance. It means height. So I'm trying to find the height of a building. Initial, u means initial velocity. When initial velocity, we're trying to find the initial velocity. Since we're trying to find the height of this building, we're going to find the initial velocity of this box before it fell. Initial velocity when the body is at rest. What is the initial velocity when the body is at rest? The initial velocity when the body is here at rest. Always initial velocity is 0. I think you remember that. Before anything falls, the initial velocity is 0. So initial velocity there is 0 times time is what? We said it takes 3 seconds to fall. The ball takes 3 seconds. Plus half. When you are falling down, acceleration is 10 or 9.81, but I'll use 10 here. Times, what's the time there? The time is 3 again. Took 3 seconds. Where did I get the time? The time is in the question. Before you forget, this is the time here. It was there in the question. That's the time. So 3 times 0, any number times 0, it is 0. So what will remain here? It's half. Half times 10 times 3 squared is 9. 3 times 3 is 9. So 2 into 2, 1. 2 into 10, it is 5. 5 times 9, 45. So the height is 45 meters. Okay, that's the answer. Question 3. Question 3 is, they can ask you, what is the kinetic energy of the box when it is halfway, to the ground. Okay, when it's halfway to the ground, we're trying to find the kinetic energy when it's halfway to the ground. But we already know that potential energy is the same as kinetic energy. Okay, and the formula for potential energy, it is potential energy is equal to how what's the formula for potential energy? Potential energy is equal to mgh, which is, what is the mass? What's the mass of this? It's actually 2 kgs. Have you seen the mass? The mass is here, it's 2 kgs. So meaning that when I'm calculating, when they ask me, when they ask for what is the potential energy when it's halfway to the ground, the question was, what is the kinetic energy of the box when it is halfway to the ground? When it is halfway to the ground, meaning it is falling, right? So mass is 2 times gravity is 10 times height is what we calculated there, h, which is 45, which is equal to 2 times 45, it is 90 times 10, it's 900. So 900 joules. And then we said, what is the potential energy when it's halfway? Since potential energy is the same as kinetic energy, so I mean, we said, what's the kinetic energy? So kinetic energy is the same as potential energy. So it means the kinetic energy is also 900 joules. But we said, what's the kinetic energy? It is halfway. So it means kinetic energy times half of that one. Half of 900 is what? 450 joules. That's the answer. 450 joules. That's how you calculate.